आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hi there, today we have a question. Let L1 be the line R1 is equals to 2i plus j minus k plus lambda I plus 2k, and let L2 be the line R2 is equals to 3i plus j minus k plus mu into I plus j minus k, and let pi be the plane which contains the line L1 and is parallel to L2. Then the distance of the plane pi from the origin is. So first of all, to solve this question, we should have the equation of plane also. So if we know the normal vector of a plane and the point through which it is passing, then the equation of the plane can be established using the formula a of x minus x1, a of x minus x1 plus b of y minus y1 plus c of z minus z1, where a, b, c are the coefficients of x, y, z in the normal vector. Right, so equation of plane generalized form is this. Now in the question we can see that the line L1 is in the plane. That means the plane contains the line L1. So we can say that the normal of the line, that is I plus 2k, will be the normal of the plane. So we can say that for first line, right, for line 1 we will have our x1, y1 and z1 as these are the points. X1, y1, z1 are the points through which the plane is passing, and since it contains the line also, so the points through which the line is passing will also be the points through which the plane is passing. So we can say for the line 1 our points will be 2, 1 and minus 1. For line 1 points are 2, 1 and minus 1. So let's substitute these points in the first equation. So we will get a of x minus 2 plus b of y minus 1 plus c of z minus 1, that is plus 1, is equals to 0. Now we have another line to which the plane is parallel. That means its direction ratio, its normal vector will also be normal to the plane. So we can again write the same equation in the form of line 2. Right, and the points where the plane is lying will remain same because the line R2 is parallel to the plane. So it doesn't contain any common point. So we will take the point from the line 1 and take the normal vector from line 2. So we will have for line 2 points will remain same as the first line, and the normal vector will now become 1, 1 and minus 1. So we will take, let me substitute these points in the first equation. So we will have the same equation as 2, right? So now we will have our in the first line equation we can see that we have I plus 2k. So we can say that a plus 0 times b plus 2 times c will be equals to 0, right? And the another one is a, b, c are the direction ratios of the plane, and this is the direction ratio of line. So if they are perpendicular, so multiplying using the theorem of perpendicularity, you can say that I into ai cap plus 0 j cap into b plus 2k cap into c will be equals to 0. Now doing the same equation for the second line will be I plus j minus k. So we will have I plus j, that means 1a cap, 1a into 1 into 1 into b plus another one is minus k. So we will have minus 1 into c will be equals to 0. From here we can say our a is equals to minus 2c, and putting this minus 2c in this equation we will get a minus c is equals to 0, and this will give us b is equals to 3c, and c is already c. So we have our direction ratios as this. Now we will substitute these values in the equation 2, and we will get a of x minus 2, that is minus 2c of x minus 2, and then plus b of y minus 1, So plus 3c y minus 1 plus c of z plus 1. So plus c of z plus 1 is equals to 0. Taking c common, we will have minus 2 of x minus 2 plus 3 of y minus 1 plus z plus 1. Solving them will give us minus 2x plus 4 plus 3y minus 3 plus z plus 1 is equals to 0. And then we will have minus 2x plus 3y plus z, and we can see that we have plus 4 minus 3, it means plus 1 and plus 1 and plus 1 is plus 2, right? So making the coefficient of x as positive, we have to multiply the whole equation by minus 1. We will get 2x minus 3y minus z minus 2 is equals to 0. So this is our equation of plane pi, right? And we have to find out the distance of origin from this plane. So origin is what? 0, 0, 0, and the distance formula is d is equals to a x1 b y1 plus c z1 plus d upon root under a square plus b square plus c square, right? Where a, b, c are the coefficients of x, y and z respectively. So we will have our formula as ax1, that is 2 into x1. x1 is now origin, right? x1, y1, z1 are 0, 0, 0. So these three terms will be 0. We will left with minus 2 only upon root under a square, that is 2 square plus minus 3 whole square plus minus 1 whole square under root is equals to minus 2 upon root under 14 under mod. When we remove mod, it will become plus 2 upon root 14, right? So this is what our distance, 2 upon root 14 units, and can be written as 2 upon root, we can write it as 7 into 2, right, units. So root 2 and root 2 will be cancelled out. Root 2 can be written as root 2 into root 2. This will become root 7 into root 2. So finally we will have root under 2 upon 7 units as the final answer. So let's check our options now. We can see we have the option 1 as our answer. So this is what our answer. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।